Okay, cool. So let's get started. Okay, so welcome to Percona Live again. If you're coming from the other session, you might have seen me there. Yeah, so I'm a bit tired because of the back-to-back presentation, but yeah. Interesting features of Postgres 13. So when Postgres 13 came out, so normally every year, September, October time, that's what all the releases will be coming out, and all the excitement happens in the community. But there will be delay in adoption, so people may delay their adoption to new versions because of multiple reasons. One of the main reason is the ecosystem around Postgres may not be maturing, like the extensions or the tooling which specific to Postgres 13 or the new versions may not be working properly. So there will be delays, and natural hesitation will be there for adopting something really new. Any bleeding edge problems could be there. So today I'm going to talk about the interesting features of Postgres 13, because during this summer season is what I generally see a lot of adoption to the Postgres new versions. And myself, Jobin Augustine, Postgres escalation specialist in Percona. I have been working for Percona for last 3 years. Before that, I was with OpenSCG and AWS. So, yeah, for a short period of time, and yeah, total 20 years with the databases, and long-term follower of Postgres community. Coming to the topic. So this is a frequent question I keep answering. Why should I upgrade to Postgres 13? So this presentation is all about create some excitement so that you'll feel like, okay, this is something I want to have. So partitioning improvements, which we skipped in the previous in my previous session. So little more details. I demonstrated how the before triggers works in Postgres 12 and Postgres 13. So before triggers are allowed in Postgres 13, which will help to migrate, by which we can even decide to which partition the data can go. And a trigger will be created on each individual partitions automatically as and when a new partition is added. So why this is important? Because everyone who migrate from normal table to partition table want to have the same experience when they move to partition table. So when they have a trigger on the non-partition table, and when they move to a partition table, they want to have the same trigger in place. But if we don't have that feature facility to support that, it may become a showstopper. So Postgres 13 has that feature, and automatically all the new tables will get that feature. And this is the partition pruning improvement, how partitions are eliminated as part of execution plan. In Postgres 13, the code become more generic, okay, and it will automatically apply the constraint exclusion more generically in partitioning. And probably this is one of the case where I saw the Postgres code improved in terms number of lines decreased, but the feature is with an additional feature, so it works better with a lesser number of code. So it's part of rethinking about how things are done. And it become more efficient. So as we mentioned, when it becomes more generic, it is applicable for even the constraints defined on the partition table level. even if we are hitting on a particular partition using query. Okay, and this is important because as we discussed, I don't know whether you participate in the other session. The Postgres partition can be even on a remote machine because it support foreign table as a partition of a partition table. So this can be utilized in sharding. So yeah, just want to mention we can use it as sharding so that even unnecessary foreign table scans will be avoided. So to make that point clear. Okay, and this is another great improvement in partition in partition-wise joining. So earlier, previously, the partition joins techniques only allowed partition joins when input partition tables are had exactly same partition bounds. Say one table is having partition bound like 10 to 20. The next the table on which to which it need to be joined also need to have exactly same bounds, say 10 to 20. Then only that partition wise join used to happen. But that may not be the real world scenario. You may want to partition some table quarter wise, some other table monthly wise, and some other table weekly wise. So now and moreover, Postgres allow you to have same table having different partition ranges. So if you have seasonal business, say during the main season, you want to have partitions of lower ranges. Yeah, and when we have that in older versions of Postgres, it couldn't figure out how to do partition-wise join. So that problem is sorted out in Postgres 13. So we have partition-wise join, even if the partition bounds are not matching. The new algorithm will find out partition of one of the partition table matches one of the partition of the other table. So it basically forms a set of pairs, as we can see in the screen. In the left side is the old explained plan, and the right side is a new explained plan in Postgres 13. It is more efficient. And yeah, so doing a logical replication on partition table used to be a big headache, because if we couldn't specify the top level partition table as a logical replication member. So the new feature in Postgres 13 is allow partition table to be logically replicated. Every time when we add or remove a partition to this partition table, it will be automatically adding and removing to the publication. And as we can see in the screen, there is a new parameter, new option for the publisher publication. So publish by partition root. So that's a new parameter. So as we can see in the previous version, Postgres 13, if we create a publication on a partition table, it used to give errors. This is no longer the case. And not just publisher part, even for the subscriber part as well. So we can subscribe into a partition table. So the applying replicated changes to target table, which is partition table, and the data goes to relevant partitions. Previously, subscribers could only receive rows into a non-partition tables or the actual partitions. Okay, since we discussed a lot about the partitioning things, getting into index improvements. And no doubt, this is the biggest benefit community considers as the biggest improvement in Postgres 13, the deduplication of B-tree indexes. And deduplication is only applied at the point where a leaf node is split, which could otherwise be required. Instead of splitting the page, it will do deduplication. So the extra overhead of deduplication is compensated. So deduplication work requires some effort, but it is compensated because the leaf page split requires more effort. So it then gives benefits without not much negative effects. And the physical representation of B-tree is not change. The physical representation is only change, not the logical. So you can deal with the B-tree index as it was previously. And when we talk about deduplication, obviously the question comes: will it be beneficial for unique key indexes? Because there is no duplicate, but even unique key indexes will make use of the deduplication for controlling the blot. Otherwise, the multiple versions need to be managed with multiple entries in the indexes. So the blot, the deduplication helps in terms of the multiple version handling in Postgres. And we are going to see other benefits as well. In simple sense, the deduplication gives lot less the benefit of the space. Okay, in the Postgres 12, the index size was in this typical case it was 215 MB, but we can see that in Postgres 13 it is 66 MB, so there is lot small. So obvious performance boost, less. So the advantages are, as we mentioned, it helps to decrease the blotting and saves disk space and memory. And because the page split, everything is avoided, it improves the transaction throughput in many cases. And moreover, it reduces the cost of index vacuuming. And I think last week I had a customer case where this was a lot more complex. Yeah, so this Postgres 13 addresses this problem. And yeah, better unique index as well. But there are some slight gotchas which we need to take care of. We should be re-indexing an existing index after upgrade. If you are doing a PG upgrade, if you are using a logical upgrade, it is taken care. But if it is in place upgrade using PG upgrade, the indexes need to be rebuilt. And there are certain cases where we should expect minor regression, especially for append only insert into table. With if there is a lot of non-unique indexes are there, so expect some performance degradation. So, but Postgres 13 provides us to provides us a feature to turn the deduplication on and off. Okay, so by default it is on, but if we have a case where it is really a problem, we can turn it off. So it gives us the freedom. And yeah, not just B-tree index stuff. We have improvements in other areas as well. Say this is gist and svgist case, where the distance operator is improved. So here we can see a case where the distance. So the workflows is whether the B is inside a box defined by the points, and ordered by the point. Ordered by the point, point's distance from the B, or B's distance from the point. Yeah. So we have two two cases where the index can be utilized. One is the where clause, as well as one is the order by clause. In Postgres 13, it uses the index for the where clause properly, but for the sort operation, it was doing its own. But in Postgres 13, it is changed. It knows it is already sorted because it's coming out of an index. So the extra sort is removed. And gene index improvements. So avoid, say earlier, in many cases, the gene index had to be scanned end to end. The full scan of gene index is avoided now, and the not clause is handled better now. Here is an example. So here's a text search query, and it is using in the double at the rate. This is for the matching. This is a matching operator. So the field of the query matches these two lexemes of the text search, and as we can see, in a nutshell, we can see the execution time become 1/10 of what it was in Postgres 13. But when we analyze the explain plan, and there won't be any change in the explain plan, but because this is the improvement in the way the index is handled, okay, because it become more efficient. Because it need to scan less, and it uses for this not operator as well as. And this is another improvement in terms of indexes. Now the index can take extra parameters. So here in this case, this is a expression index or a function index where the text lexemes are indexed. Earlier, we didn't had a control on the signature length, but now we can control the signature length of the index, by which we can adjust the lossiness of the index, higher the signature length, it become more accurate, but the index may take more space. And as we can see, when we describe the table, the same signature length will be displayed. This is even in the psql side, we see these improvements. And optimizer improvements. And here we can see this is the similarity operator. So the city similar to Warsaw is selected. So in earlier case, we could see it is handled differently because the cost was not accurate. The estimations went totally wrong. So this is just estimation. So earlier the estimations were showing that only 20 rows are expected out of this. That's why all these sort operations. So when we have poor estimate in the inner nodes, those will result in a lot more wrong execution plans in the outer nodes. So in this case, Postgres 13 on the same data, it gave very accurate estimate of the rows, and it resulted in a different execution plan. Obviously, it was faster. Okay. And another great improvement in Postgres 13. All of you know that we can create extended statistics, especially when we have a correlated column. Say, for example, the capital of a country and the country code. So there is a correlation there. So if we are storing both into a table, we have a method by which we can tell database that these columns are actually functionally dependent, or there is a relation between them. So all these things are possible using extended statistics. And now in Postgres 13, we can specify even the statistics target. So basically, we can specify the sampling rate, how many rows are to be sampled, so that it will become more accurate. And obviously, it will become the resulting query will be selecting best execution plan compared to the previous version. And this was not possible in all versions, of course. Yeah, here this is an example of creating extended statistics for as we can see in the screen, creates a special extended statistics, the functional dependencies on these two columns, A and B, for this on this table. And there is a dependency between other two, C and D. In older versions, this kind of dependencies were not fully taken into account. So the best one was selected, best one among all the extended statistics were selected, and that resulted in poor execution estimates. As we can see, in this case, and in the Postgres 12, it was the rows were estimated to 9. But in Postgres 13, it is more accurate. And we can see the actual rows are 64, and it is very close to that. The estimate is very close to that. So all these are resulting in better query planning and query executions. And here is another example. Postgres 13 functional dependencies are support only for equality clauses, but now that's not the case. We can use it for or in or any kind of cases. So this is an example. The value is checked in clause and clause. In Postgres 12, it came up with a very poor estimation. So it estimated to return only 2 rows, but there were actually 100 rows returned by the node. But in Postgres 13, it's very accurate, say exactly same value. So good execution plans again. And some of the important points you should remember is, in general, the both in and any estimates are improved. Okay, but any with comparison is not benefited. So there is this is a non-inequality comparison. So such comparisons won't be benefited. And all also won't be benefited out of this improvement. But yeah, not all the cases are fixed. Say a step forward. So a lot more queries are getting better now. And this is another improvement. So I have this is a select statement with a subselection, and this subselect returns a constant which is joined with a table. And Postgres 12 used to do what we have written. So it execute the function and join that with the table and do a join with that table using a hash join and return the rows. But in Postgres 13, that it understands this is a constant. This returns a constant, and it will be used along with the scanning of the table. It will be evaluated during the table scan itself. So instead of as we can see, it's a 5-step process. This is a 2-step process. It's lot improvement. And okay, we talked about execution plan improvements, planner improvements. So we are going to see general performance improvements. So incremental sorting. Okay, what is that incremental sorting? Say we can see in this query there is a order by clause in the inner query, and there is another order by on the outer query. So the data comes out of this inner select will be ordered already, and then need to perform additional ordering on the outer query. Yeah, so what the Postgres can do now is it can do the group wise sorting. So take the inner sort. So this is too simple example. If there are multiple keys, it can do the innermost thing sorting. The grouping will help to sort in multiple steps. So it's an incremental sorting. It results in much better performance. So as we can see in Postgres 13, the same query is resulting in incremental sorting. And again, we can control this behavior using a new parameter. A new Postgres parameter is introduced, and we can turn it on or off to control this behavior. And generally, this reduces the memory consumption and the possibility of writing to temporary tables, displays basically. And reduces the startup cost, especially when we have a limit clause. Okay, in this case, I have a limit clause. That's why it becomes more efficient. And new performance improvement for data sorting, for handling INET data. INET data is your IP addresses. The Postgres generally handles a lot more types of data. We discussed about the geometrical data types. So this internet address, IP addresses is one of the another type of data, which is very basic as well. There is a huge performance improvement when we deal with INET data in Postgres 13. There are testing showing that up to 50 to 60% reduction in sorting time. Yeah, and the difference increases as the size increases, and this because this IP address is becoming more of a primary candidate for as a data type these days, because we have a lot of these IoT devices and machines pumping the data into databases. So we are going to get a lot more IP address data into databases. So please select INET data, and you are going to get much performance improvement. Okay, another big improvement again in Postgres 13. The old versions were avoiding this hash aggregations when the data is expected to use more memory than the work memory. Okay. So Postgres will won't use hash aggregation at all. And if Postgres selects hash aggregation by mistake, if the hash aggregation is selected by a wrong planner, it do further damage. It will keep everything in memory, irrespective of how big it is. Yeah, so it consumes a lot more memory, and yeah, and we may even get into out of memory situations. Yeah. But now hash aggregation plan can choose the disk. It can be triggered even if it's not fitting into work memory. It can be selected, and it can use disk. That is a major improvement. The hash table will be spilled into disk when it exceeds the workmem. And again, we have a new parameter to control this behavior. It's a multiplier. What is a multiplier of the workmem on which the data need to be spilled into disk as a temp file? And this is again auto vacuum improvement. A big improvement, because one of the another pain point in modern world, because I talked about IoT devices which is continuously, or machines which is continuously pumping data into databases, which is those kind of data is kind of insert only workload. So data is getting inserted but not getting updated. So but all existing calculations of auto vacuum, how to trigger a auto vacuum, was based on the dead tuples. When we have a insert only workload, though all those calculations won't help us, because there is not dead tuple, only inserts are happening. So but we should remember that the vacuum has a lot more usage than just handling the dead tuples. We need, one example is freezing. And yesterday's talk, I mentioned about how the vacuum handles some of the special indexes like Brin or Gin. Yeah, so auto vacuum has a lot more work to do than just cleaning up the dead tuples. So auto vacuum should be triggered on the tables even when there is insert only workload. So now Postgres 13 introduces two more parameters. So again, I'm talking about a lot more parameters. So two more new parameters: auto vacuum insert scale factor. In older versions, we had auto vacuum scale factor and vacuum threshold. So now we have insert scale factor and insert threshold as well. So this will trigger the auto vacuum on the tables, even in the case of a insert only workload. And yeah, so there is again another parameter is introduced to control the IO concurrency. This is similar to effective IO concurrency in older versions, but the effective IO concurrency was mainly used for the foreground workers, so for the session processes, for deciding on the effective concurrency. But this is deciding on the backend maintenance, backend workers. Like say, one example is the valve prefetches for recovery. So there are a lot of things happening in the background. So what is the concurrency which can happen on the backend process? So this will be this parameter will be handled on the behalf of many client sessions. So and why this parameters are becoming more and more relevant these days is because the storage level improvements. Now we have a lot of the new types of storage devices which can support a lot more concurrency than the older versions. Say we have SSDs or NVMe devices. Okay, so this gives better performance. And another advantage of this parameter is this can be specified at a table space level. So if you have a table space sitting on old slow disk or cheaper slow disk, and we have some archive table sitting there, we don't have to increase a lot of IO concurrency there. But when we have our hot data, our active data set is sitting on a SSD or NVMe device, we can change this parameter at the table space level to improve. So it can be specified at the table space level. So the meaning of this parameter is the number of simultaneous requests that can be handled efficiently by disk subsystem for the background maintenance workers. Okay. And again, another parameter. Sorry, 1 second. Okay, So just making sure that everyone is seeing my screen. Okay. Yeah. Um, the val writers can skip if val level is kept minimal. So especially when the tables are recreated. So this is useful for the migrations. We can keep the val levels minimal. So the val generations become very less if the tables are created or recreated. And so we have a parameter, as I mentioned, what is the minimum table size at which the skip should be taken into effect. So default is 2 MB. And there are a lot more other improvements in Postgres 13. Some of them are listed here, replaying the drop database, and truncate table, and the third one is a lot more important for the SQL performance. In Postgres 13, it won't fetch all the uncompressed, compressed toast into for decompression. It will be taking only the leading bytes of the toasted values. So if you have for example, if you have a select query with some string percentage, so any string which starting with that query, that string should match that. The entire toasted data need not be decompressed. And coming to monitoring improvements. So I'm skipping over a lot of things. I won't be able to cover everything in the short duration talk. Yeah. Important improvement is about explain or auto explain, or even the Postgres logging. We have provision to see the val generation. So here is an example. I have an update statement, but when I execute explain analyze with val option, I'll get how many val records are generated, how many full page images are created, and total how many bytes. So every statement we can figure out how much of val generation is happened. And it is not just for explain or auto explain. We can have the same information for all the auto vacuum, the background auto vacuum workers. The bottom one is Postgres log information. As we can see, the val information is recorded at the end for the auto vacuum. So we have more clarity about the val generations, and it is available from explain, auto explain, and Postgres logs, or even from pgstat statements. And there is a lot more improvement in statement logging with the statement which is captured into Postgres logs. So all of us knows that, and from older version itself, we had this logmin duration statement. So every statement which crosses this time limit will be logged into the Postgres log. So we consider it as a slow query. Okay. And then the problem is a lot more very fast running queries won't be captured into logs. But we need some samples of those fast running queries as well. So in Postgres 12 introduced this log transaction sample rate. So samples of even the fast running queries will be captured. So we can specify a sample percentage or the value. And in Postgres 13, it is further improved. We have 2 more parameters to control the sampling. So we have a logmin duration sample, which is specified the minimum required statement duration for sample. So only those statements which crosses this time limit will be considered for sample, and those samples will be captured in the sampling rate. say we can say 10% or 20% of those queries. Yeah, and effectively these new parameters is standing between these two cases. So login duration statement captures everything which is at the highest limit. So the idea is the new parameter log min duration sample should be ideally less than the log min duration statement. So we can have samples of the fast running queries as well. This is a really good improvement for analysis. And coming to Postgres logging, so now we can log even the backend type of each of the backend processes, which was not possible earlier. So we all know that the logmin the logline prefix, where we specify what are the data need to be captured as part of the each session. So now there is a new marker added. It's a %b, which will capture the backend types. So for those who are thinking what is this backend type, we can query on pgstat activity. We can see what are the backend types. So Postgres logs will have clear information. This line is coming from these backends. This line is particular to this backend. So it is we can add this to it is already part of CSV log. So we can optionally add this to log line prefix if you are using normal Postgres logs. And another improvement in Postgres logging. Now we can control the prepared statement. There is improvement in prepared statement logging, and the previously prepared statement parameters were never logged during errors. So now we have two parameters to control that. The maximum length. So the explanation is given here. Log parameter max length. This is the maximum length of the parameter values output during the logging of non-error statements. Even if the statement is true, still this will decide on the maximum length. And this is for error condition. Same for error statements. So we can capture the parameters even on error condition in Postgres 13. And skipping to system views improvements. Every Postgres user knows this pgstat activity. This is probably the most queried view. And now we have the leader PID added to this pgstat activity. Now we can see for each of the parallel workers what is the leader PID. So for these parallel workers, the first line is the parent. So because the user session may be because you see this is a client backend. So when the user see the client backend, the user may see only this PID, but the parallel workers are there doing the job. So this will help to track parallel query execution through pgstat activity. It's a very good improvement. And another big improvement, pgstat progress base backup. So this was a problem when we take backup of a big database. So now we can see the progress of the base backup. So there will be one row for each val center process that is currently running base backup replication command. So base backup is actually using a replication command behind, it's called base underscore backup. So there will be one entry in this view. And in this example, we can see it's in progress. So total is this much, and then so far completed is this much. So far it's streamed. This is just before the completion. So everything is completed, and table space also completed. So immediately after this, the backup comes to an end. And another view for those who are monitoring. So we know we can monitor the auto vacuum, the vacuum. So because we had a view pgstat progress vacuum in the previous version, but now we can even monitor the analyze. So what is whether this analyze statement analyze is working. This includes even auto vacuum workers. So as we can see, it is the analysis doing some sample, acquiring some sample rows, and the progress. So we can even monitor the analyze, which is good. And this is for hardcore people. We can look at the shared memory allocation using this new view, pgshm SHMEM allocation. And the view shows allocation made from server's main shared memory segment. This includes allocation by Postgres itself and memory allocated by extensions also. So in this case, we can see the pgstat monitor. This is a extension developed by Percona, and we can see the memory, how much memory it allocated. And but it won't help memory allocated using dynamic shared memory infrastructure. But yeah, so, and there is a lot more to discuss about the monitoring part. We have other view, pgstat slru to monitor internal slru caches. And we can have track activity query size to up to 1 MB. I don't know, somebody will write that big query, but we have option to capture such a big query as well. And wait event improvements. And we have a lot more wait events. This is the Postgres wait events is something which I personally use regularly to assess where to assess the performance of Postgres. So where the time is spent. So now we have dynamic shared memory segment allocation wait events, and vacuum delay, and both val archives and recovery process also has a wait event associated. So they are backup wait, val archive, and recovery pause. And another is recovery conflict snapshot and recovery conflict table space. So we can understand whether where it is hanging or where it is slowing down. So this is one of my favorite topic to monitor wait events. I don't have time to go into details, but yeah. Streaming and replication improvements in Postgres 13. Okay, this is wonderful feature. Earlier, if there are multiple nodes and if we want to reconfigure the topology, we want to change the standby to point to another primary. We had to update the primary connection information and restart the server. So there could be a lot of reporting jobs running on the standby, and looking for a restart may not be the right thing to do. But in Postgres 13, this can be done online. So you can just specify the primary connection information about the new primary, and just signal using the pg reload conf. It will be coming into effect. So no downtime required. So I know there are people who are trying to solve this problem for years. It was a burning issue for many of the DBAs. Yeah, it's solved. And this is another problem case. When we have a PG-based backup running on a big database, a big Postgres instance, there could be a concurrent checkpoint happening during that PG-based backup. So Postgres automatically removes, could remove, especially the val logs, which is actually required for the PG based backup. So now that won't happen anymore, because the PG based backup creates a temporary replication slot. So all the val logs will be retained till it completes. Okay, and again another new parameter. So val receiver create a temp slot. So by default it is off. Yeah, you can turn it on. Yeah. And another pain point for older versions were we had many cases where people running into this problem, where some of the replication slot will be remaining in the server, and it will be retaining a lot of val files in the location, and it fills up the entire directory, the val location, and end of the day the database goes down. Okay, it was really painful. So now that won't happen anymore. So we have a parameter, new parameter, max slot val keep size. If you can specify this, Postgres will make sure that we are not crossing this limit. Because the stability of the data, the database is important than retaining certain logs. If standby goes out of sync, we can even rebuild that. But if the primary database crashes, it may be a lot more painful for most of the users. So, but we have parameter to select the option. And please remember this: any replication slot that would require exceeding this value are marked invalid. So if there are other replication slots holding this old vals, those replication slots become invalid with this change. And this is something may affect people with a surprise in older versions, because when they try to promote a standby, it may not happen. It may be stuck in the pause mode, because what was happening is by chance, if the standby is in pause mode, it will stay there without promotion, because it's the essence is that the recovery pause had higher priority than the standby promotion, but actually we want the other way, most of the users. So the solution is, now in Postgres 13, if you issue a promote request to Postgres, it will complete the recovery as soon as possible and allow the server to become primary once the as quick as possible. So it won't have the pause won't have priority over recovery. It will be in the reverse. The promotion is has higher priority than the pause. Yeah. So this was another problem in older versions. If standby a standby would promote itself upon reaching the end of the val, even though the PITR target is specified something else. So suppose we have a target which requires a lot more vals to be applied, a lot more road to go, but there was an end of the val happened, and what standby will do is it will promote itself. This is not what really should happen. So the new solution is the recovery, it will error out. Instead of promoting, just error out. This will be the error message: recovery ended before configured recovery target was reached. And then now the DBA has an option to correct, or if some val files are missing, now DBA can go and copy those val files, or make provision for copying the things, so that we can complete the targeted recovery as we want. No more surprises. And yeah, so all of you deal with the logical decoding, logical replication, maybe knowing that there is a the logical decoding spills the decoding files into disk, and now we have control on that. So again, new parameter, logical decoding work mem. The default is 64 MB, by which we can control the logical decoding memory. And this was another problem in the old versions. If there is a corrupt val file, the recovery will get into trouble. Postgres will raise a panic error and abort the recovery. But actually, that's correct. But we may are in a situation where we don't have other backup. The only backup we have, but the val records are corrupt. We want to proceed the recovery some way. So just turn this parameter on. Again, new parameter. Ignore invalid pages. So the recovery can be proceeded. And there is lot more improvements, commands, functions, and the parallel vacuum. We can specify the vacuum to run in parallel mode now, but this is not available in auto vacuum. This is available only in the manual vacuum. So if you have a supplementary vacuums and things like that, or if you are triggering this from your command line, you may make use of this. What it does is this triggers parallel index vacuuming. And the user specified value and the number of indexes will be considered for the effective parallelism. And there is other limit, the max parallel maintenance workers. So the minimum of all this will be considered for the parallelism. And this is a SQL improvement. So now we can write queries with fetch first rows with the ties. So I have a tie for a same value. So 2 rows will be returned. This is like the fetch first rows is like a limit and offset, but this is more of a standard, and many of the database systems has this. So now it supports even rows with the ties. Oh, sorry. It can be utilized even for cursors. Yeah. And buffer usage statistics now will be available for even the planning phase, and especially when we have JSON or XML or YAML format explain outputs. So in this case, I'm generating a JSON plan, and as we can see, the planning gives complete information about the buffer information about the planning phase. And this, I think everyone may not be knowing this. So when we have a generated column on a table, and if we want to copy data from another table, insert into table from another table may not work, because say for example there is a serial identity column which need to be inserted automatically. We can specify overriding user values. So the values coming out of this table will be overridden by the what it is actually specified in this table, the generated values. But this used to work only if for those columns which is generated by default. But now in Postgres 13, that limitation is removed. It works even for generated always columns as well. So copying data from table to table with the generated columns is much more easier and friendly. And sorry, we are running out of time. Multi-step alter statement. So this we can have it multi-step alter statement which affects multiple columns, and we can have if not exist check. So if this column is not existing, then only create, add that column. So if this column is not existing, create and make it a primary key. For creating the primary key, there should be an index as well. So create that as well. So we can have an alter statement with which is doing a lot of things. So it was not doing the right things in older versions, and for example, if we execute this particular statement in Postgres 12 multiple times, the second time execution will fail. Actually, this shouldn't fail because there is a check if not exists, but it will fail in Postgres 12 or older versions. It won't be failing in Postgres 13. This is so all the scripting, the SQL scripts will improve, and there is a lot more improvement. The alter view can rename columns, drop database force. There is a force option, as I mentioned in the example. If you use that, all the connections will be terminated and the database will be dropped. Otherwise, we need to wait for everyone to drop the connections. And client tool improvements. Now PSQL is showing the transaction status by default. So if you say begin a transaction, it will show an indication that the transaction is started. And if there is an error, it will show that the previous statement resulted in error and the transaction is aborted. So this is very useful when we deal with the command line options. So in older versions, we had to set this explicitly, and this is very handy. And new thing, this is a new thing. We have a secondary prompt with which can be specified as %W. So instead of Postgres prompt coming repeatedly, this will give a empty space. So this is useful for especially when you take screenshots and prepare documentation. This looks much more clean. The Postgres the prompt won't be repeating again and again. And another thing is the /g and gx command can be used for changing the pset output for a single statement. So we don't have time to explain that. And pgbench, there is improvement. We can have a partition for pgbench accounts by default, and many of you already knows that pgbench can accept a lot more scripting. We can have custom pgbench jobs other than the built-in pgbench tables and things like that. When we have custom pgbench workload, which we script, we have a lot more options in Postgres 13. Yeah, and which earlier such options were available only on PSQL, but now the pgbench scripts are becoming more powerful. We can generate a lot more types of workload for Postgres and test it. And another improvement is pgbench can now generate initial data on the server side. Earlier, the pgbench used to generate the data and connect to the server and push all the things to server. But now the data can be generated to the server side. And a few improvements for DBAs. So we have a backup manifest, and we have option for verifying the backup. And the PG-based backup can estimate the progress, and the information will be available from the view which we already discussed. And there are very good improvements in PG Rewind. PG Rewind writes recovery configuration with a new parameter, right? Recovery conf. So otherwise, manually we had to handle that, right? Now we can just pass. This behavior is similar to PG-based backup, because PG-based backup can generate a recovery.conf, and PG Rewind can use the target cluster's restore command to retrieve the vals if required. So there is a new parameter, restore target val, PG PG Rewind, PG Rewind can do automatic crash recovery before rewinding. So no longer we have to handle it manually. And there is a parallel execution possible with the vacuumdb and indexdb command line utilities. So there's lots and lots of improvement, but I won't be able to cover everything. So thank you for listening to me. I hope you are excited about the improvements in Postgres 13. Please consider upgrading. Thank you, everyone.